Hey everyone, this is Bhargav Suthar, and today we are going to learn what is a predicate logic. So, first of all, let us understand what is a predicate. So, a propositional function, we all know that what is a propositional function or a predicate in one or two variable is a sentence that becomes a proposition when variables are given definite values from the set of values it can take. Okay. So, for example, this x is greater than 13. Then next, y plus 8 equals to 12. So, whenever we put y equals to 4, then it will become 4 plus 8 equals to 12. Then it will become a predicate. Okay. A predicate P contains n variables. X1, x2 up to xn is called an n-place predicate. For example, x is greater than 13. See, we have only one variable, x is greater than 13 is a one-place predicate and it is denoted by the simple symbol p of x, simply p of x. Now then x plus y equals to 12. It is a two-place predicate and it is denoted by this p of xy and so on. So whenever we have one variable, we will denote it by p of x. Whenever we will have two variables, then we will denote it by p of x comma y and so on. Now the values which the variables may assume constitute a collection or a set is called the universe of discourse. Now we will have total two quantifiers. The first one, what is the universal quantifier? So if p of x, it is a predicate with the variable x as an argument. Now then the universal quantifier is a mathematical symbol and that is for every, whose meaning is for all. Now the proposition, see, for every x comma p of x, and which is interpreted as for all values of x, this comma p of x is true. Again, this symbol for every x p of x, it is interpreted as for all values of x p of x, it is true. Now a variable x is said to be this universally quantified as it is a universal quantifier. Now the second quantifier is the existential quantifier. So if p of x, it is a predicate with the variable x as an argument, then the existential quantifier, it is a mathematical symbol. A universal quantifier, it was this for every. So in an existential quantifier, it is there exist, this rotated e, so whose meaning is there exist. So the proposition for every x p of x, which is interpreted as there exists a value of x in the universe of discourse for which p of x is true. In universal, it was for all value of x, p of x is true, and here there exists a value of x in the universe of discourse for which p of x is true. Remark, see, the negation of the given statement for every x p of x is for every x p of x is not true, or it is not the case that for all x this p of x is true. So that means at least for some x p of x is true. So in other words, there exists an x such that not p of x is true. Okay, again I am repeating the negation of x p of x, that means for every x p of x. So what is for every x p of x? It is for every x p of x is true. Now we want to write its negation. So for every x p of x, it is not true. So that means it is not the case that for all x p of x is true, or in other words, there exists an x such that this not p of x is true. So in symbolic form, for every not of, that means negation of for every x p of x, and that is equivalent to for every, there exists x such that p of x is not true. That means negation of p of x. This we will use in some of the examples, and this is important. Let us discuss examples. The question is over the universe of discourse. So that means whatever the values it can take. So over the universe of discourse of book, here book, defined propositions. So the first one, b of x is given, x has blue color. Then second, m of x, x is Matt's book. Then third, I of x, X is published in India. Then the question is, translate the following. See, the first one is in symbolic form. For every X, M of X and I of X implies B of X. So the first one is in symbolic form, and second one, there are maths books published outside India. So second one is in sentence form, and then we will have to convert it into symbolic form. So both are different. So what will be the solution? See, the first question is for every X, M of X and I of X and implies B of X. Now what is M of X? M of X is maths book, and what is I of X? X is published in India. So that means we will have to combine both these statements. So X is maths books and it is published in India, and that implies this B of X. And what is B of X? It has blue cover, and outside this bracket there is for every X. So that means for all. So after combining all this, we will get all maths books. So that means all for every that means all. Now maths books, that is M of X, published in India. So that means I of X, and implies B of X. That means X has blue cover. So that means all maths books published in India have blue cover. So this is how you can translate. Now the second one is there are maths books published outside India. So it is in sentence form, then we will have to convert it into symbolic form. So there are maths books. So see, there are maths books. So that means we will use existential quantifier. Okay. Now maths books published outside India. So first, maths books published. Okay. So it is a maths book. So it will be M of X and published outside of India. So we have I of X that is published in India, but here we have published outside of India. So we will use not of I of X. So what will be it? So there exists X such that M of X, that means it is a maths book and it is published outside of India. So that means M of X and I of X. Okay. So let us consider a second example. Rewrite the following statements using quantify variables and predicate symbols. So the question is, all birds can fly. See, we will just divide it into 2 or 3 parts, whatever the parts are. So the solution, let P of X. See, the sentence is all birds can fly. So let P of X is X is a bird, and let Q of X, X can fly. Okay. So the statement can be written as all birds can fly. So all means, that means we will use universal quantifier. So that means for every. So for every X, this P of X, that is X is a bird, and implies Q of X, that means X can fly. So for every X, P of X implies Q of X. Then next, there is a student who like maths but not geography. So we will divide it into how many parts? Let us check. So let P of X is X is a student, then Q of X, X likes maths, and R of X, X like geography. Okay. So there is a student who like maths but not geography. So there is a student. So that means we will have to use the existential quantifier. So the statement will be this: there exists first. Now there is a student. So there is a student. So that means P of X who like maths. So that means Q of X but not geography. So that means not of R of X. So there exists X such that P of X and Q of X and not R of X are true. So this is how we can write. Now next, each integer is either even or odd. So first, again, what will be P of X? That means X is an integer, X is an integer. Then next, Q of X, X is even. Then R of X, X is odd. So there will be total 3 statements. So the symbolic form will be, see, there is each. Okay. So for every X such that this P of X, that means it is an integer and it is either even or odd. So P of X, and that implies Q of X or R of X. So this is how you can write the statement. Then next, negate each of the following statements. So for every X, this modulus of X equals to X. So what will be the negation? See, for every X, the negation is there exists X, and it is simple. Modulus of X equals to X. So its negation will be modulus of X not equals to X. So the combined statement will be there exists X such that modulus of X not equals to X. Then next, if there is a riot, then someone is killed. So we'll just divide it into two parts. So let P equals to there is a riot, okay, and Q, someone is killed, okay. So if there is a riot, then someone is killed. So the given statement is what? It is P implies Q. That means if there is a riot, then someone is killed. So P implies Q is there. Now we want to negate this statement. So what will be the negation of P implies Q? Okay, so negation of P implies Q, that is, now we know that P implies Q is equivalent to not P or Q. Okay, so negation of negation P or Q. Now just multiply negation, so we will get negation of negation P, that is simply P, and this not of Q is not Q. Now we will convert it into statement form or word form. So there is a riot, P means there is a riot, and not Q, so that means someone is killed. So there is a riot and someone is not killed, or no one is killed. So this will be the statement. Thank you.